Hello and welcome back. My name is Amir, and in this video we're going to talk about the puzzle on day 16 of Advent of Code 2022. So this puzzle was one of the harder ones in my opinion in the series for 2022, and it was like a graph traversing algorithm with like around 60 nodes and with changing values, and we should traverse it like for depth of 30 minutes that has been provided here in the puzzle. So it would like take forever for a computer to compute this such a huge graph. So we should come up with an idea. So but before that, let me draw something to show you what's the idea behind this puzzle here. The thing is, we have a bunch of valves or nodes, and each of them has a value and they are connected to different nodes. Like for example, if this is A, this has the value or the flow rate as like 0 here, but this is connected to B and to C, and each of them has a flow rate. This for example is 0 as well, but this is like 5. It would take 1 minute opening a valve here or moving from this to any of the directions, and then 1 minute opening the other node. So if we have a graph like this, after 2 minutes the most amount that we can gain is 5. We would get 1 minute moving to here and 1 minute opening this. But having like 60 different nodes that are all connected is making it much more complex. So for example, if we have a D here and an E here, and for example D is like maybe 100 and E is like 5, the optimal way would be after like 3 minutes that go from A to B and from B to D and then open D. We would gain like 100, although we have wasted 2 minutes moving from A to D, but we have gained like 100 in the end. And suppose we have like 50 here. This is F, and we have 4 minutes, and we can do this. So our optimal would be like going to from A to B and B to D and then D to E. We would gain like 1 nothing and then nothing and then 100 times 2 because we have 2 minutes left, and 5 times 1. So we would get like gain like 205 if we follow this path. But if we follow like this path, it would give us 5 times 3 for moving from here to here and opening this. 5 times 2, sorry. And then 150 here. So this path would give us like almost at most 60, but this path is much more better, although we are wasting like 2 moves moving from A to D. But the key to this puzzle is that is this point where they said there is no point in opening those ones that have the flow rate of 0. So this is a hint for us, and it's hidden in the puzzle, that we should avoid the ones that have 0 because it would make our life much more better. How? If we look at here, we would see that from like 50 something valves that we have here, like 70 or 80% of them have the flow rate of 0, and we can easily ignore them because we don't gain anything by opening them. So I think this is clear now. Let's go to the code and I will show you my approach to solving this puzzle. So as always, we are just reading the file here and splitting and everything. Then I will have a graph here of the nodes and some rates. These will include values for the graph and for the rates. Like, so this is the graph from whichever valve to other valves. So from QZ we can move on to the other ones. And if I get the rates here, it will be the rates that each of the valves has. So QT has 13, and these are the valves that we should ignore as we move along. So we have these two in place. Then there is a distance object which includes the distance from every node to other one. So this also is something like this. So from each and every point, like for example this valve to this valve, the distance is 12, but from BY to VG it's 2. And these are the main ingredients that we want to solve our puzzle. But but before that, how do we find the distance from one point to another in a graph? This is done here, the magic is done here. We have a nested loop here on the graphs that we have, on the valves, I mean, that we have, and we are getting the start and end. So we are checking for all the graphs, like here. We will get all these and we will check, okay, from this one to this one, what is the distance? From this one to this one, what is the distance? And so forth and so on. And that is basically, if we don't have the start, then we would add the start. We say, okay, this is one of the nodes that we want to have the value for that. Otherwise, if we have already figured out the distance from one of the points to another one, then this value is valid. We would just add the end to it. So we would say distance from A to B is the find distance from this from our graph with this start and this end. And the find distance works like this. This is basically BFS algorithm that we have a queue and we have a list of the visited ones, and so if the start and end are the same, then the result that we should return is 0, because there is no distance from point A to point A. Otherwise we just push the start to our queue and we will go on until we find the end in the neighbors from that point. So in a nutshell, if we want to go from A to E, we will check that A is connected to B, and then from B to D is like 1, and then from B to this valve, which is E, is also 1. So from A to E is 2, and so forth and so on. So for example, from F to E would be like 1, 2, 3, 4 steps. We have another route which is like 5 steps, going from F to C and C to A to B and B to D and D to E, but the optimal path is like 4 steps. Okay, this is the find distance function. The next thing that we want to do is just to filter out the valves that are not 0. So I mean filter the valves that are 0, so we would just keep the ones that are not 0, in other words, and then find the rates starting from AA to all those valves. And how this rate works, rate is basically working on the distance from AA to all the non-empty valves and the amount of the time that we have, which is 30. This is like the main part of the algorithm. It takes all the rates and put them in the variable all rates here, and for all the remaining nodes that are those ones that are not AA and are not empty, we would just loop through them and find the time that is, needed to get to those and open them. If that time is less than 1 and our time is finished, then we would return. We cannot do anything. Otherwise, we will get a new list of the opens, so that I'm doing this to have a new object from the opened ones to be added to the new opened. And I would say, okay, for this one, this amount of time is left. And then the new amount of the left valves is the same as what the left valves were, but just splicing out the one that we already are checking at this moment. And when all these computations are done, then we would push the find rate to all our rates, and when all this stuff is done, we would return all the rates. And this is a like a huge object which includes all the rates going from AA to all the nodes. So if I log all the rates here, you would see that it has too many rates, too many rows here, and each of those rows is like from AA to all the other paths that are available in the graph and not the empty ones. So as you can see, we have like 209,000 items here, and this is just basically by removing all those non-empty ones. If we have included those ones, this value would be much more bigger. However, when I have these values, I will map through them and find the value for those ones by just doing this calculation here, and then I will get the biggest one and then return that. So this was part one. The link is always in the description for you to check out and come to better ideas with that one. For the part two, the thing is that we have only 26 minutes. This is one change. Instead of having like 30 minutes here, we have 26 minutes. And then it's not only us that we are opening the valves. There is one elephant that is helping us in opening the valves. So we have two different paths that we are moving along. And we should come with the highest amount as puzzle number one. So everything is the same. We are getting all the rates as we did in the part one, but there will be two more loops here. One is this loop that will help us get the max scores for each node, and this is basically going through all the keys and all the entries in the rates and finding the max score for all of them. And then when this is done, I will have another nested loop for the max score for human and for elephant. And then we would assign a set to all the valves and compute the values that each human or each elephant will choose from the path. And then when we get to the end of the valve, when the size of the valves that we have here, which is a set, is the same as the human length and the elephant length, which means that both of them have chosen a bunch of valves, the optimal valves, and we have reached to the end, then we would get the highest based on the previous highest that we have already found and the new high value for the max score of the human and the elephant. And then we will return the value. I really recommend you go and check the code in my GitHub. Maybe you can come up with much better idea instead of going throughout all the valves here. But at the end of the day, this was my solution to this puzzle, and yeah, that was it. That was it for today. Day 16. Actually, it is not day 16. It's like 29th of December. But I need to solve all the puzzles in this series. So there will be 2 more videos for day 18 and day 19 of the series for this year, so that I can complete all the puzzles for this year, and then the Advent of Code 2022 will be finished and we will move on with other interesting ideas. So thank you again for watching and have a great day.